After completing this lesson, you will be able to apply and remove coping, create beam systems, and create trusses. The objective domains covered are 1.1e, work with structural framing and connections. Coping can be applied to structural framing and structural columns when two or more members intersect. By default, steel framing has a join cutback of 1/2 inch. In order to add coping, you will need to edit the join cutback and then apply the coping. Coping is a fast alternative method of cleaning up drawings and the model when steel connections are not being modelled. If a steel connection is placed on the beam, then many traditional Revit tools such as coping and cutting beams are deactivated. Beam systems are very convenient when adding a number of joists to the framing bay. The span direction can be controlled and the beam system will adapt if the boundary changes. A beam system can be used in 2D or 3D, so is very useful for adding light gauge steelwork, perhaps on vertical planes. A truss is an assembly of beams and bracing elements that form a rigid structure when assembled together. They are typically found in roofs and floors where long spans are desirable. Revit can create any type of truss, and trusses can be attached to floors and roofs, which will then remain associative back to those elements. Go ahead and open up the model 010, Work with Structural Framing Part 2. You'll note that this particular model opens up in the second floor top of steel plan. If we zoom up to the front of the structure, here we're going to begin by adding in some beam systems. Click the structure ribbon and then select Beam System. On the context ribbon, you'll note that we have two methods to create a structural beam system. We can use Automatic Beam System or Sketch Beam System. We also have the ability to tag these on placement. I'm going to choose not to tag these. And on the options bar, we can configure the beam type that we want to use and the layout rule. In our case here, we'll go to maximum spacing, and here we'll set a maximum spacing of 8 feet. You'll now note that as I move my cursor over closed framing bays, Revit previews the beam system. When we're ready to place the beam systems, we can simply select, and you can see the beam systems are then placed. Let's go ahead and review that in 3D. And you can now see our secondary beam systems placed. Next, we used the same beam system to put some framing in these roof bays. On the structure ribbon, go ahead and select Beam System. This time, you'll see that we have a different context menu. First thing we're going to do is set our working plane. So here, we're going to ensure that we have reference plane, roof plane selected. This is an inclined plane where the girders are modelled. In this example, we can simply pick the supports for our beam system. As I pick each support, you'll notice that this symbol here is determining the framing direction. That's correct, but if I wanted to change that, I could use the beam direction mode, and then I could pick another beam. Once I'm happy with this, I can select Finish Edit Mode, and my beam system is placed. So I may choose to edit my beam system, so I can simply select the beam system, and then in the Properties palette, I can make some changes. So here, for example, I might want to change the section size. And you can see the beam system updates. Next, you model two trusses to create our sky bridge. In the project browser under Structural Plans, let's go ahead and open up the 4th floor. Our sky bridge needs to go from the core to this area over here. And you'll notice we have two structural columns underneath the slab to support our sky bridge. The sky bridge is going to be modelled with trusses. On the structure ribbon, select Truss. Let's review some of the settings in the Properties palette. So you'll note here that the bearing cord is on the bottom, and also our bearing vertical justification is also set to bottom. The truss height is 8 foot, and you can see here we're using a custom family for our sky bridge. If I click on Edit Type, here we can review some of the sections that we're using. So the top chords are using our square section, same with our vertical webs and our diagonal webs, and the bottom chord is again using the same as the top chord, a slightly deeper square section, in this case 8 by 8 inches. Both the vertical webs and the diagonal webs are using a 6 by 6 inch member. So here I'm going to create the truss from the end point of this wall to the center point of this column. And we'll do the same on the other side. Let's switch back to the 3D view to review our truss. And here you can see our sky bridge. Now, the sky bridge is pitching up at the start. Let's review some of the properties. If we select this truss here, you may note that the start level offset is set 1 foot above the end level offset. Well, with any structural framing or trusses, we can obviously amend and edit these settings. I could change the reference level for my truss and the start level and end level offsets. In this case, let's set the start level offset to 0. And you can now see the truss adapts. We'll do the same with the other truss. We'll set the start level offset to 0. Another thing to note with a truss is it doesn't have to be vertical, so we could take this truss and we could rotate it through 90 degrees. Also, the bearing cord could be set to the top rather than the bottom, and you can now see the truss is set out from its top chord. Okay, so there's the sky bridge created with the trusses. Next, we look at beam column joins and coping. Let's start with beam column joins. So on the roof section here, you can see that we have stub beams over here carrying these rectangular hollow sections. And you can see if we look at the condition at the end of these RHS sections, we really need to tidy those sections up a little bit. If you select the Modify ribbon, you'll note here that we have a tool called Beam Column Joins. If I go ahead and select that tool, you'll notice here that we get arrows where we can direct each section. So here you can see that this member is butting up to this member, but I could reverse that by shortening this top member and then increasing this member here, and now I have the opposite configuration. Without shortening the member, if I push this member into this member, then it forces a mitre. So let's look at that again over here. So again, I can push these two members together and form a mitre. And I'll do the same over here. And one more in here. Let's now go ahead and look at coping. In the project browser, go ahead and open up the second floor plan. Let's zoom up on our beam system. And here we're going to create a section to elevate this joist. So on the quick access toolbar, select section. And we'll create a section that's going to elevate that joist. We can change the depth and go ahead and open up the section. We'll change the scale and also the detail level. So here we can see our joist and also our girder. The first thing we'll need to do is extend our joist into the girder. Before we do that, if we select this joist, let's take a look at the properties palette, and you'll notice here that we have something called Start Join Cutback and End Join Cutback. By default, this is 1/2 inch. So that's given us a 1/2 inch gap between the edge of this beam here and the bounding box of our girder. What we're now going to do is override that. On the context ribbon, you'll notice we have Change Reference. Let's go ahead and select that. Instead of cutting back to the bounding box of the girder, we can now pick the web. and you'll now see the joist has extended. On the Modify ribbon, we can now click Cope. So here we select the member we're coping, and then the member it's coping back to, which is our girder. Once we've created the cope, we can also control the gap. Let's select the joist. In the Properties palette, you'll notice here we have coping distance. So I'm going to update this and have this as 1/2 inch. And there's our notch. Now, just so we can see that notch in 3D, let's go back to our 3D view. We can right mouse click on our view cube, and we're going to orientate our view to section 1. Of course, here we can now see our joist, and we can now see the notch into the girder.